Hi, I'm Libby, and I'm here to talk to you about OB math, all right? It's easier to do it this way, to kind of walk through a couple of different questions and give you tips on the different kinds of math you're gonna encounter on the OB unit, but more importantly, on your OB math test. So, here we go. First, I'd like to talk about the Pitocin calculation questions, all right? It's a whole new world for many of you. The issue is Pitocin is available in units. That's it, the measure. The unit of measure is units. And it's in milliliters because we put it in IVs, right? So you got units of Pitocin in milliliters. We run the IV in milliliters per hour, but the dosing of Pitocin is milliunits per minute. Oh, trying to put all that together, you can see how it can get confusing. So I break it down. It's called dimensional analysis for anyone who likes fancy terms, but I just want to break it down how I do it so that you'll have a clue coming into this whole program. All right, so there's two pieces of information that remain constant no matter what. Those two pieces of information, unless something's changed, you let me know. There are 60 minutes in 1 hour, right? All right. So I'm going to put that up here, 60 minutes in 1 hour. All right. The other piece of information is that there are 1,000 milliunits in 1 unit. I don't know if you knew that before, but you know it now. 1,000 milliunits, that's MU, in 1 unit, which is U. Now, any Pitocin calculation question will give you two more pieces of information. The first piece of information will always be the concentration of the IV bag you're working with. You need that. You need to start somewhere, okay? So for these purposes, I'll say there are 30 units of Pitocin in 500 milliliters, all right? So there's another piece of information, 30 units in 500 milliliters. The question will go on to give you one of two things. It'll either give you the IV rate, which is milliliters per hour, or it will give you what the patient's dose is, milliunits per minute. So for these purposes, I'm going to say that the IV rate is running at 6 milliliters per hour. 6 milliliters per hour. So the question asks, what dose is the patient receiving? So now you know that if it's asking for a dose, it's asking for milliunits per minute. So to keep me focused, I come on over here and I write milliunits per minute over here, so I remember what it is that the answer has to be, all right? Dimensional analysis says you need to use all 4 of these fractions, and you can flip them. You don't have to flip all 4 of them. You can flip them as you need them. That's another point. And if you have to use all 4, and if hour, say, is on the bottom, and this hour is on the top within the equation, they cancel each other out. So if something's on the bottom and something's on the top, it gets canceled out. It'll make sense in a minute as I'm writing this out. So I know the answer to this question has to be in milliunits per minute. So I'm going to start using these fractions with the milliunits, the one with milliunits on top. So that's this one. So I start the whole equation with 1,000 milliunits in 1 unit. Cool. So as long as I don't cancel that out, milliunits is on the top. I don't need units, so I'm going to go over here and find the one that has units in it. That's this one. Because units is on the bottom, I'm going to make sure units is on the top for the next fraction. And I'm putting, so far I haven't had to flip any. 500 milliliters. All right. I don't need milliliters, so I'm going to try to cancel out milliliters. That's this one. So put that one here, 6 milliliters on the top, and 1 hour on the bottom. And then finally, I want to cancel out hours and make sure minutes is on the bottom. I'm going to flip this one so that hours is on the top, 1 hour, and 60 minutes is on the bottom. Makes sense so far?
Yes.
So I'm canceling out hour, I'm canceling out milliliters, canceling out units, leaving the end result milliunits per minute on the end. So then you just multiply the top, 180,000 over 30,000, if my math is correct. Over 30,000. Simplify that fraction, then it's 6 milliunits per minute. Does that make sense?
Yes.
Yeah? All right. With that in mind, I'm going to do it asking the opposite question. So, sorry. See me bending over. Should I leave that up there? I think I probably should. So I'm going to keep everything the same, meaning the concentration, but instead of giving you the IV rate, I'm going to give you the dose. So, whole new question, these being the same, but the other piece of information is 6 milliunits per minute. And it's going to ask, what do we set the IV pump at? So when it's asking about IV pumps or IV rates, we'll erase this for a minute. It's always wanting you to do milliliters per hour. So milliliters per hour goes over here to keep me focused, right? All right. So, just so I know I'm starting on the right track, I'm gonna find the one that has milliliters in it and put that on the top. So that one, either one really, but I'll just start with this one. I'm gonna put 6 milliliters on the top per hour. Oops, sorry, wrong thing, sorry. We were doing 6 milliliters per minute. All right, sorry. Okay, so milliliters. That's this one. 500 milliliters. So we're flipping this one. 30 units. So we flip this fraction so that milliliters is on the top. We don't need units, so that would be this one, right? Putting this one, flipping that one too, so they can cancel each other out. 1,000 milliunits. All right, I'm gonna cancel out milliunits, so I'm gonna use this one, keeping it this way. Is it making sense so far? A minute. And I'm gonna cancel out minute, making sure hour is on the bottom, so I get to keep that one the same too. So flipping. Per hour. Cancel out minutes, milliunits, units, milliliter per hour, and it's the same math, leading you to 6 milliliters per hour. Make sense? All right. As for rounding, when we're dealing with like kilograms, I don't care what you round it to. You can round it when you're dealing with adults. Round it to the nearest whole number. I mean, if you're dealing with 80 kilograms, what's half a kilogram? But if you're dealing with a newborn baby might only be 3 kilograms. So if you're rounding to the next whole number, you're actually rounding up or down a significant fraction of the kid's weight. So I don't want you rounding to the nearest whole number when it comes to newborn weights. In fact, we weigh our newborns basically in grams. So you know, it could be 3,234 grams. and we dose things in kilograms, so just move the decimal point over 3 and you don't have to, and just leave the 3 decimals. So round it out to the 3 decimals. So there's no, if you for some reason going back and forth between kilograms and grams, you're not taking any of the kids' weight off. Does that make sense? Just at least 2 or 3, but 3 means you know what the entire weight is without having to guess or round. All right. In any kind of equation, when you can round, be aware that if you round with every opportunity, you could round to a different answer in the end. Like if you round with like every step of an equation, you could actually change the answer. So I would hold off and round to the at the end of your equation or at the end of your problem solving. That's one thing. What else? There are questions that are asked in real life and say on an OB math test that give you a lot of information. There's no rule or law that says you have to use all the information that you're given in the question. So be aware of what the question is asking. I always, because I gotta keep myself focused, I read through the whole question and then I kind of underline if I can, or at least pull out what the question's asking. What are you gonna set the IV pump at? Well, if it's what do you set the IV pump at, you know the answer has to be milliliters per hour. And then you go back and say, what information do I need to solve this problem? And take what you need, but you don't necessarily have to take all that's in there, okay? Some people want to use all the information the question's providing. And they will get the question, they will get the answer wrong because there's some information you might not need. You had a question.
I think you answered.
Did I?
Somewhere.
You had a question about,
I had several.
thank you. Somebody had a question.
For kilograms, there was a couple questions where the answers were rounded differently. Like there were 2 questions where one of it rounded to the nearest whole number, and the other one rounded to the 100th. I don't know, like for the quiz purpose, like what should
Well,
we do?
just like I said, I would go with, if it's an adult weight and a large number, round to the nearest whole number. Sorry, there's something crazy. Yeah, but if it is an infant weight or a smaller number to begin with, then take it out a few decimals.
Okay, so it's not like super strict about,
So few
because
meaning
for
too.
some, like it was, they were both
it's an
children and they did it weird. Like they said, one was
14,
rounded, yeah.
One was 14, one was like.
When it was like really 13.5 something, and they
Wow.
rounded it to 14. So I didn't know.
14, yeah. I won't give you any more. I won't give you those on this
Okay.
OB math test anyway. We're dealing with an adult weight. Like I said, it can go to the nearest whole number. Infant weight, take it out the 3 decimals. Just so if you're converting back from pounds and ounces to grams,
Okay.
you don't have to guess on any of the numbers.
Okay.
Now I'm not gonna. Now in terms of other rounding, have you ever tried to drip a half a drop?
No.
So if you're something like 15.6 drops per minute, like if you're doing a drip factor or whatever, good luck trying to figure that one out. Obviously you're gonna round up or down with that. With milliliters per hour, there's no decimal points on IV machines unless you're in the intensive care unit, perhaps, I don't know. But so you can round to the nearest whole number on those things. For OB math purposes here, I'm not going to I'm not gonna mark you wrong if you say 12.5 milliliters per hour instead of 13 or
Okay.
whatever.
They did that in
Yeah.
our last math quiz for 210, that's why I was asking.
No, I'm not, because the math is correct and that's really what's important. What other questions do you have?
The glucose one,
Mhm.
so there's 2 of them. One of them was, they were both the exact same questions with just different numbers.
Mhm.
So one, the glucose was 243, and her carbohydrate consumption was 50 grams.
Mhm.
So it said to go off of what her glucose level was.
Okay.
So that would be 3 units. And then for the carbohydrate consumption, it would be
5.
5. So that answer was 8, which
Okay.
makes sense.
Mhm.
But then on this bottom one, it said her glucose level was 316, which means she would be getting 8 units.
Uh-huh.
And then her carbohydrate consumption was 150 grams, which means she should have been getting
15.
What was it, what did they say for the,
yeah, so she should have gotten 15. So, now I'm confused.
I don't have my glasses on.
The answer was 31.
I thought it was 28
Yeah.
because you do the 15 plus the 8.
Right, yeah, that's what I got.
Oh,
So, yeah, so the bottom line with that is that you
you do both
You
separate,
do both.
right? Okay.
You add
That's
in,
what I was asking.
what the current blood sugar is,
It's 20.
you're medicating that based on
Yeah.
the sliding scale.
Right.
And then you're adding an additional couple of units or whatever,
Mhm.
depending on how many carbohydrates they're eating with that meal.
Okay.
As far as, these questions go. So whatever that particular plan is, we should do the math just to make sure that you're cleared up there. Any other questions that other people have? How many ounces are in a pound?
16.
16. So if I'm converting pounds and ounces to kilograms,
Divided by 2.2.
right. So if I got if I'm saying that a baby weighs 6 pounds 4 ounces, it's not 6.4 pounds, right?
No.
It's actually 6.25,
16 divided
Right?
by 4,
Yeah,
right?
4 divided by.
right? So it's actually 6.25 pounds divided by 2.2, or multiplied by.
You do 4 divided by 16.
Yeah.
Divided by 2.2, yeah.
Got it.
Yeah, see what I'm saying? So make sure it's because it's not 10 total ounces in a pound, so
Mhm.
you gotta make sure you're using the right fraction when it comes to that. I think those are the main things. This system works with Pitocin calculations. You can use dimensional analysis to solve some of the other math questions in nursing, but it's not you still have to look at the bottom line, because if you're looking at solving a magnesium sulfate question, which there's some of those on there, we're not looking at what the dose is per minute. So there's no minute to hour conversion so keep in mind what the question is at. That's the main point, is look at what the question is asking you to solve. I guess that's it. Thanks.